Welcome to this podcast on the overview of Gotwals courses. This is a podcast designed to walk through some of the logistics of taking one of the 5 courses in computational science that I offer through the NCSSM online program. Some quick philosophies about my courses. The foundational question that I want you to be able to answer by the end of the course or courses that you take is, how does computing and mathematics help us solve interesting, challenging, and complex problems in the natural, the physical, and the social sciences? So basically, by the time you're done taking one or several of the computational courses, you should be able to talk about how computing and mathematics help us to solve problems in a wide variety of areas. The strategies for doing that is on having you use, modify, and/or build computational models. And we do that using a variety of software tools and resources. And I want you to learn how to solve problems by solving problems, which sounds sort of silly, but the idea here is that the majority of the things that you're going to be asked to do in my courses is to tackle real problems that are found in the research environment in chemistry, physics, biology, or whatever the topic area is that you are studying. And it's a little bit of process versus product. And what I mean by that is sometimes you're going to be learning how to solve these problems by spending most or all of your time trying to build the computational model, and that's sort of a process approach. And sometimes you'll be trying to solve problems in the sciences by using somebody else's computational model, and that's sort of a product approach. So sometimes just building the model is how you're going to learn about things. Sometimes using a model is going to be how you learn about things, and sometimes it's going to be a combination of both of those things. All my courses have a research focus. Most of them are the labs, and we'll talk about the labs in a few minutes. Start with a research question. Typically, you're going to have 2 labs every week. One of them is going to be somewhat of a structured lab, and the second lab is going to tend to be a little less structured, a little bit more open-ended, where you have some ability to bring some creativity to the problem you're being asked to solve. All my courses have a final research paper, which for the most part is completely unstructured. In scientific programming, I have a little bit of structure. In MedChem, I have a lot of structure. But in all of my courses, you're going to be required to come up with a topic or to complete a small research project and prepare a research paper at the end of the course. In terms of assignments and grades, this is what you care about. There's almost no bubble form types of problems. I do give you some chapter reading questions that have multiple choice, fill in the blank types of responses. But the real emphasis is on looking at data, generating data, and trying to describe what that data means. So the bulk of the work you're going to be doing is in the laboratory. That's where the most points for your grade is going to come from. Sometimes you'll be building models to generate data and then try to evaluate it. Sometimes you'll be running models and getting data and then be able to use that data to figure out what's going on. Now, my courses really aren't right answer types of courses like you might find in, say, AP Calculus or AP Chemistry, where there's clearly a right answer that you're expected to be able to choose from a series of multiple choice types of questions. And what I might suggest and what I hope you're doing is think about my courses or think about the AP type courses as the courses you're going to use to get yourself into the college you want to. Okay, my courses are more designed to help you be ready for doing research at the undergraduate level when you actually do get accepted into the college that you're applying to. A little bit about general weekly structure and assignments. You should all know that there's a 60-minute webinar or video conference on your assigned night, whether that's Monday, Tuesday, Wednesday, or Thursday from 8:30 to 9:30 p.m. And the goal is to prepare you for the week's labs. So the typical structure of these is you have 2 labs every week. for the most part. I usually spend the first half hour talking about the first lab and then the second half hour talking about the second lab. You also have some weekly assignments. There's something called a question of the week, and that's always due by Saturday night at 11 p.m. And that's a chance for you to be asking questions that are content-based, not questions about what your grade is or how many points something is worth or how to do some lab, but thinking creative questions about the material you're being asked to look at during that given week. I will answer some of these questions, and they really are required reading. You will have a final exam, and a lot of times I take final exam questions from the questions of the week. You'll have chapter readings with questions, so there'll typically be a chapter reading every week or every other week. There'll be a YouTube podcast with questions for you to take a look at. I have a YouTube channel, youtube.com/GotwalsB. A lot of times, especially for the more advanced courses like computational chemistry and medicinal chemistry, you'll have a journal article from the scientific literature to read on a every other week or so basis, and those come with questions. And then, of course, your labs. Lab 1 is always due 2 days before the end of the week, and a week means when you start. So, for example, if your webinar is on a Tuesday night, your first lab is going to be due on Sunday, and your second lab is going to be on Monday, because your week starts on that Tuesday. So that you need to plan your schedule accordingly. Course management, we use the Canvas course management tool, and for every week you'll see what's called the week in review. It gives you the topic, what we're doing that week, and it spells out in pretty clear detail every day of the week. So here's one for, say, computational chemistry. Our webinar is on a Thursday night. It tells you what we do on Thursday, what we do on Saturday, what we do on Sunday, Monday, Tuesday, and Wednesday. And you should see when the labs are due based on what I just said about when labs are due. So this is, if you have questions about when something is due or some activity, this is where you go to get that information, the weekend review. Student support, I do tutorials basically 5 nights a week via WebEx video conferencing. Sunday night, it's typically 8 to 9:30. That's subject to change depending on if it's a holiday weekend or if I'm traveling. Monday night, I don't have, for the fall semester, I don't have a class on Monday night. I will in the spring. But for Monday nights in the fall, tutorials will be from 7 to 9:30. Tuesday 7 to 8, Wednesday 7 to 8, and Thursday 7 to 8. Okay, so that's when you can come ask questions and get some help on labs. Email, I read email pretty much all the time until usually 9:30 at night. I don't read any email after 9:30. So if your lab is due at 10 o'clock and you're sending me email questions at 9:45, you're going to be out of luck because I will not be reading them. I would strongly encourage you to read email that I send. I will send out frequently will send out mail with tips and tricks, suggestions, words of advice, things to think about, things to look at, especially regarding the labs. I have a lot of study guides or handouts in Mathematica, which is the primary software tool that you're going to use for all of my courses. There's podcasts, what I call Bob TV, on YouTube. A lot of times I'll do what's called a 5-minute film. If a couple of you are asking me the same question, that means more than one of you has a question about something. I'll film a quick 5-minute film and post it on YouTube so that everybody can get that question answered. And there's a Facebook Computational Sciences group, which is a good place to go to get a little bit of help or talk to each other and get some suggestions on labs and other activities. It should be noted that I don't respond well to panic. So if it's Tuesday night and it's 9:15 and you're just starting a lab that's due that Tuesday night, you're probably not going to get much sympathy or much help from me. So if you don't start on your things early and get your questions answered earlier in the week, you're not going to get much support from me. Computing tools, we make heavy use of Mathematica, sometimes referred to as MMA. We're in version 10, I think 10.2 now. Almost all the labs use Mathematica. The download install instructions are on Canvas announcements. We use a lot of specialized software. It's class dependent. Everything we use is cross-platform, meaning it'll run on a Mac or a PC. All of it is downloadable for free. You don't have to buy any software. And software must be downloaded and installed at least 3 days before a lab is due. I have a lot of people who, if a lab is due on Tuesday night, on Tuesday afternoon, they're emailing me saying they can't figure out how to download or install the software that they need to use for the lab that's due that night. And I'm going to be unwilling to help you if you wait till the last minute to get software downloaded and installed. As a cautionary note, you need to back up files. I have a zero tolerance if you have a hard drive failure and you lost your work. I'm not going to have much sympathy for you, so make sure you're doing backups. Okay. You need to think about what happens in the case that your computer breaks. You're going to need to think about having a backup computer that you can do your classwork on. I don't have any way of replacing a computer-based activity with something that you can do on paper and pencil. There's just nothing that I can give you to do to make up that work. Some schools will not allow you to load software on public school machines, so especially if you're dual enrolled and you're using a school computer to do your work, and you're having trouble getting software installed, you need to let me know, and I can try to help work with the people in your school to get software installed on machines at your school. Grades and weighting. Here's sort of the breakdown of how things get graded: weekly homework, readings, podcasts, questions a week, 10% class participation, 5% labs 30, final project 35, and a final exam is going to be 20. We are now on a 10-point scale, but you should know that at NCSSM, regardless if you're dual enrolled or otherwise, a failing grade is a D, and that's a 70%. I always get a question about when my lab will be graded. I teach a little heavier load than most faculty at science and math. And this year I have a little more than 80 students in the online program. So if you do the math there, if you look at this chart here, if I'm spending on average 10 minutes per lab, that's about 26 hours, 27 hours a week just of grading. So I'm going to work hard to get grading done as quickly as I can, but there will be times when I get a little bit behind. Just keep an eye on Canvas and you'll be able to see when things are done. Other grading issues, I have what's called a late fee. And what that means is there's a 20% penalty if you turn work in late. And that comes with a 15-minute grace period. So as an example, if an assignment is due at 10 o'clock p.m. and it comes in at 10:16, that means I start the grading at 80%, which means the highest grade you can get if the paper is perfect is an 80%. And typically if you're turning it in last minute, that means it's probably anything but perfect, and you can count on getting a 70 or a 60 or lower if you're turning things in late. If the assignment comes in at 10 p.m. the day after it is due, so 24 hours past when it was due, then grading starts at a 60%, and then I grade from there. And the Canvas clock is the official clock, so if you send me an email that says, but my watch said it was 10:15, but Canvas says it's 10:16, then I go by the Canvas clock. Okay. Other grading issues with webinars, with attendance, you get two what I call excused absences. They're not really excused, but I drop 2 of your attendance grades. So you need to think about if you know you have a sporting event, or you have National Honor Society, or you have somebody's birthday you want to attend, you need to plan ahead, and those will be the ones that you miss. You've got to manage your time. Okay, you are expected to be at all the webinars. You have to decide priorities. So please don't send me email saying that you have to go to a banquet for National Honor Society, or you have a track meet, or you have a Boy Scout Court of Honor. Okay, you can miss class for those things, but you have two 2 sessions that you can miss without penalty. After that, your grade will be penalized. You don't need to advise me that you're going to be absent. If you're going to be absent, just be absent, and I'll record it appropriately. For grading for the webinars, there's a 5 quick quiz at the end of every session, and that quick quiz is based on what I say during the video conference. The goal there is to get you to pay attention to what we're doing in the video conference. I have a lot of students who will just log in to the webinar and then they will go watch TV or do some other homework or do some other activity. So this quick quiz was implemented to prevent that from happening. And the grade that you get for attendance is, on the quick quiz, that's your attendance grade. So if you get 3 points out of 5, then your grade for that webinar is a 3 out of 5. And again, 2 attendance grades are dropped. A special note for senior, and this is more for the spring semester than it is in the fall. If you're taking any of these 3 courses, know that there is an end of semester project that started in mid-May. So if you think you're going to have a bad case of senioritis, you may want to think about not taking one of these courses. Okay, other considerations, some questions I hate the "is it right" question. Okay, the idea, and I hate the "how many points is this worth." Okay, there's no, for a lot of the things I'm going to ask you to do, there is a right answer, but I'm not as concerned that you get the right answer as you think about what the data was telling you, what you think the data means, and that you're using some intelligence to try to figure out what's happening. The how many points is this worth? Every assignment that you get is going to tell you how many points it's worth. You know how much things are weighted, so you shouldn't be asking me how many points something is worth. Okay, a good student will use computer models, modify computer models, or create computer models to solve some particular problem. A good student will collect data. A good student will analyze data in an intelligent way. And an intelligent might mean that you get the right answer, okay? But intelligent could also mean you don't get the right answer, okay? It could be that you applied some pretty smart thinking and ideas to the data you had. You didn't quite get the right answer, but you demonstrated that you were thinking about the problem in what I consider to be an intelligent way, and you will get your grade will reflect that, even if you don't get the right answer. What do I want from you guys? I want you to learn how to think. I want you to learn how to learn. I want you to learn other academic skills like how to write, how to compute, how to problem solve. Obviously, I want you to learn some computational science. And what I want is that you are ready to go work in an undergraduate research lab with your computational skills. So that's the way I measure my success, is how many of you want to go do undergraduate research and how many of you are able to get a job as a freshman undergraduate in some lab doing computational science. What do you guys need? I know you care about grades. You should understand that a B in an NCSSM course is a good grade. Okay, so I don't hand out A's too easily. A lot of you are going to want a teacher recommendation letter. We'll talk about that as we get close to May, when rec letters are, we're starting to talk about rec letters. There's UNC Chapel Hill. And there's other rewards. So you see these are some comments that I cut and pasted out of Facebook. Like Celia had her first chem lab, and it wasn't too bad for her because she was ready. There's in the middle one, there's somebody who got a job based on what they learned at science and math. And the last one is, somebody talking about what they learned in computational chemistry and how they were the only one in their class that knew what they were talking about. So if you have any questions, you can talk to me during the video conference. You can come to a tutorial, or you can send me email. So good luck with courses, and we'll see you online.